This video is for lesson 3.16 for review packet 3D. Suppose x is problem 8. Suppose x is a positive number less than 1 and close to 0. So that means it is a positive number, but it's less than 1. Whatever the number is less than 1 and very close to 0. So the number could be something like 0.125 or 0.254 or very close to 0, but it's less than 1. We have absolute value of x, 1 over x, x squared, x cubed, and the square root of that number. So whatever the number it is, you just take some examples. Okay, you take any number, and then you plug that in there. So absolute value of 0.25125 is will be absolute value of 0.125 is 0.125. And then for this one, 1 over x, you go 1 over 0.125, and then you perform the operation 1 divided by 0.125, and you'll get some number. And for this one, you're going to square that number, and you get some number. And you do that for this one, and you do that for this one, and you're going to line this up in order. Which one's the greatest one, which one's the least one. This one should be on the left, and then you just line that up. That's what you do for number 8. Number 9, they're talking about the small magnitude negative number greater than -1. So we have -1 here. We have 0 here. That number has to be greater than -1, so it shouldn't be less than -1, so it's not -2 or -3. But it has to be negative number, so it has to be somewhere over here. So it's going to be probably like -0.25, or some number like something like that, somewhere in between -1 and 0. That's the number they're talking about. You do the same thing what we did for problem number 8, and then line that up. Problem 10. Says, suppose x is a large magnitude negative numbers less than -1000. So we are talking about the big number, large magnitude, so that means it's actually less, but the number has to be less than -1000. So let's say this is 0, this is -1000. It has to be less than that, so you can choose any number you want as long as it's less than. So it's somewhere over here. So it could be -2000, -3000, -3405, or -2 million if you want. And you do the same thing, absolute value of x, and 1 over that number, and cube the number and square the number, and line that up from least to the greatest. That's what you do for problem 10. Problem 11. Standardized test prep. Choose the rule that shows the relationship between x and y in the table. So we have x and y table. We have -4, -1, 0, 3, 7. We have 49. We have 9, 0, 1, and 16. What's the rule here? 7 becomes 49. By how? 3 becomes 9. By how? So -1 became 1. How? Right? So those are the rules. Find the rules first. Is the rule y equals -3x plus 4? Is it? So let's plug the number in there. So x is -1, so we have -3 times -1 plus 4. Would that be 1? No. So this is not the rule. Try B, which is y equals 4x. That might work, for one number, for example, if you plug in 0, it will work. 0 equals 4 times 0. That works, but you want to make sure that it's not going to work if you plug in this combination, So y will be 9. Is that equals 4 times 3? No, right? So it has to be satisfied. You should choose more than 2 numbers. Problem 12. Find the number of points of intersection for the graphs of each part of the equation. So you have problem 12. Part A, we have y equals x squared and y equals x to the third power. So now what we can do is, we know this y and this y is the same number. Therefore, and these two numbers are equal. Therefore, this number and this number has to be equal, right? That's what's called the transitive property. So if y equals y, then x squared equals x to the third, right? What number can we put in there? One number we can put it in is 0, obviously. 0 squared equals 0 to the third power. There's another number, and I want you to find that. So for B and C and D, you do pretty much the same thing.